I developed an AI capable of playing a racing game inspired by Initial D, featuring winding mountain roads. Before watching the 500 replays generated by this AI, let me briefly explain how it works. The game used in this project is set on mountain passes reminiscent of Initial D. The user interface is inspired by Initial D, while the driving physics combine arcade-style excitement with simulation elements. Special attention was also given to the sound design, including engine noise, exhaust notes, and tire sounds, to create the most realistic driving experience possible. To drive around the course, the AI first needs to understand its surroundings. To achieve this, I implemented a radar system that measures the distance between the vehicle and nearby walls. The AI collects the following information: steering input, throttle input, brake input, lateral velocity, longitudinal velocity. In addition, distances to walls are measured in multiple directions around the vehicle. To simplify training, all distance values are normalized using a 50-meter reference range. The visualization clearly shows the distance between the sensors and the roadside. However, simply collecting this information is not enough for the AI to drive properly. Instead of imitating human driving behavior, I used reinforcement learning, allowing the AI to learn through trial and error. As it drives around the course, TEAI controls the steering, throttle, and brakes on its own, receiving rewards or penalties based on the outcome. In addition, each generation consists of a total of 100 cars running on the course simultaneously, and learning progresses based on their respective results. The following reward rules were used during training. Penalty for driving the wrong way beyond a certain distance. Penalty for colliding with walls. Reward for traveling longer distances. Additional reward for completing the course more quickly. At the beginning of training, the AI can barely drive at all. By repeatedly failing and succeeding, it gradually learns how to corner and manage speed effectively. Once training is complete, the AI can drive while continuously analyzing the game environment in real time. For every frame, the AI measures distances to nearby walls, feeds the information into the neural network, predicts the optimal driving action, executes the predicted action in the game. This process is repeated thousands of times while driving. In short, the AI autonomously navigates the course by continuously evaluating its surroundings and selecting the best steering and throttle inputs. Now, let's see how well the trained AI performs. And they're off. A clean start for everyone. For this run, I'm using a total of 500 AI cars, featuring 100 vehicles from each of the 20th, 25th, 50th, 75th, and 100th generations. Any car that hits a wall or posts a terribly slow time will depart. The original audio was absolutely deafening, so I've turned it way down for this video. Please enjoy watching the AI cars drive for a while. Listen to that engine revving up at the braking point. It sounds just like a roaring bull. This track has some pretty intense elevation changes, but the AI cars have learned to handle them smoothly. They've successfully cleared this intense uphill and downhill section as well. Both the ascents and descents look absolutely solid. Now, can they keep up this pace? Well, they've now reached the midpoint. Next up is the tricky S-curve. Let's see how they handle it. They've successfully tackled the tricky S-curves as well. By this point, the surviving pool has been heavily weeded out. Man, I lost count of how many cars had to plunge off the cliff throughout the training process. The final obstacle, the high-speed corner, was cleared without a hitch. This is a notorious spot where many generations used to drop like flies. It's getting pretty quiet now, isn't it? Only a few corners left. Will the AI make it to the finish line? It's the final corner. Cleared. At this stage, it feels less like a race and more like a victory lap. And there's the finish line. Goal. The time is 3 minutes, 21 seconds, and 43 centiseconds. It might not be the fastest lap time, but successfully clearing the course so smoothly, and getting this whole simulation environment up and running, is a massive step forward. Thank you so much for watching until the end. I'm planning to keep pushing the boundaries with more challenging AI projects, so if you enjoyed this video, please hit that subscribe button. See you next time.